Today we will be looking at a football experiment. In an experiment, a subject is blind if he or she does not know which treatment he or she is receiving. This prevents the subject from consciously or subconsciously altering his or her response. It is also possible and usually beneficial if the people collecting the data are also blind. If the subjects and the people collecting the data are blind, the experiment is called double-blind. The place kicker on a high school football team notices that he seems to kick the ball further when the weather is warm compared to when it is cold. Of course, this could be several reasons for the difference. Maybe his leg muscles are looser when it's warm, or perhaps the ball has less resistance as it moves through the air because warmer air is thinner. Alternatively, perhaps the air inside the ball is warmer, increasing the pressure inside and making it kick better. To investigate, the kicker decides to do an experiment to see if he can kick a football further after it has been heated compared to when it is cold. So your explanatory variable will be the temperature of the football. My response variable will be the distance it's kicked. The randomization will be the order in which the footballs are kicked. And by that I mean warm and cold. The variables you need to control, you would need the same type of football, the same direction, the same tee, the same placeholder, weather, the wind, and you could go on and on. As I've said before, just make sure you have an equal number of answers to the number of points for the question. Will the kicker be blind or not? Yes, they'll be blind because the placeholder is the only one touching the football. How would you simulate the experiment? So we would take 10 note cards, and write the distances kicked. On them. Then we would shuffle and randomly assign five to warm and 5 to cold. Then we would calculate the mean of each pile. Subtract warm minus cold. Plot it on a dot plot and repeat many times. So our HO, B, the kicker has the same ability to kick a warm football and a cold one. Our HA would be the kicker has a greater ability to kick a warm football than a cold one. The experiment was complete and the first set of results are shown below, as well as the means. So my test statistic would be 59.4 minus 56.2, which is 3.2. So my p-value, they're just above 3, would be 10 out of 100, or 0.1 or 10%, whichever way you like to write it. My conclusion would be we failed to reject HO. We do not have convincing evidence that the kicker has a greater ability to kick warm footballs than cold ones. If we made an error, what type of error could we have made? Well, we failed to reject. So that would be type 2. We said that the kicker had the same ability with warm and cold footballs. But it was greater with the warm footballs in reality. In this experiment, replication means making sure that each treatment has an adequate number of trials so that any difference in the effect of the treatment can be identified. An article from the Arizona Daily Star on September 8, 2010 tells the story of a gym trainer in London who swears by the power of milk to help him recover from workouts. The article goes on to describe how milk includes many of the same ingredients as sports drinks, but also includes other proteins that help rebuild muscles. Supposing you wanted to design an experiment to see whether milk is better than sports drinks for helping football players recover after weight training. So the explanatory variable would be the type of drink, the treatments, would be milk and sports drink. The response variable, in this case, we're going to choose the amount of push-ups. So the amount they can do the day after. A hard workout. And why? Because those who recover faster should be able to do more push-ups. What variables are important to control? So you need to control the strength program or the workout. Because you don't want someone to have an easier one than another person. You also need to control the other things they eat and drink. So that everyone is having the same nourishment. And also probably the amount of sleep. So some aren't more rested. How will you incorporate randomization and why is that important? So you will randomize the order in which the players are chosen. For the treatments. So that those who have greater natural ability will be equally assigned. Will the players in the experiment be blind, and why does it matter? Well, they obviously will not be blind because they'll know what they're drinking. It matters because they may have some preconception or may already be biased toward one or the other. So the hypotheses that we'll be using are HO would be the players have the same ability to recover from a workout with milk and sports drink. And our HA will be the players have a greater ability to recover from a workout with milk than a sports drink. And our test statistics, since we don't actually have numbers, our test statistic would be the mean push-ups with milk minus the mean push-ups with sports drink.